All right, let's get started. Hello, everyone. My name is Andrea, and today I'm going to talk about the risk of remote code execution in legacy applications in Python. Or better, I'm going to talk about how you can tell your developers that working with legacy applications is dangerous. So I work for Equinor, and I'm part of an enabling team dedicated to application security. And our purpose is to reduce cybersecurity risk in the Equinor software development lifecycle. The team will be 3 years old next week, and we are 9 people spread across Trondheim, Stavanger, and Bergen. And we are an enabling team as defined by the team topologies book, meaning that we have no power whatsoever. We don't own any code except the one we write ourselves for our internal tasks. But our role is to enable and empower the development team across Equinor to do the right thing, to write secure code, to not expose Equinor to needless risks. We do this in many ways. We maintain a set of security tools, and we help developers setting up these tools and use them. We run workshops, like on authentication authorization, secret scanning. We organize events, and we try to do as many things as possible as open source. So if you go to this website, you can also access most of our material. And among other things, we maintain a network of security champions. We have about 250 people in there now. And this presentation actually comes from a request from the Security Champion Network. We try to get 1 person from every development team. We're not even close, because we have about 700 development teams estimated. And we ask these security champions to make their teams aware of the risk that comes with writing bad code. They told us that they have a bit of a hard time, because when you talk about security, it's a bit about religion. If you don't understand it, you just have to believe what the experts tell you, and that's not always easy. So this is a reusable presentation. It's very easy to adapt to your context. And the idea is that these security champions could take this presentation, run it for their team, run it for their managers, department, line, whatever, product owners, and make them aware that there are risks in the stuff we're doing. The things I'm showing is a toy example, and if you are in security, you will notice some obvious blunders. But it's realistic enough that we've seen developers reacting to it. So we think it works pretty well. So the starting point is an example problem. Assume that there is a reservoir simulator software that is configured with YAML files. And this simulator has been used for many, many years in the company. It works. It gives pretty good results, but it's old and it's hard to maintain. On top of that, this might use some data that is restricted. I don't know, like seismic data, scans, data about your installations, or pipelines, etc., etc. So everything must happen in a confined environment to reduce the risk that this data is leaked. What we know is that simulations can run for maybe even for a couple of weeks. But then if the YAML file is misconfigured, the simulation can crash right before finishing or midway through. And we want to avoid that. So as developers, we are tasked to create a small tool that can check this configuration before running the simulation. This has to be done using a library that is provided together with the simulator, meaning that our application will also have to run in the same environment where the binaries from the simulator are placed. And the problem is that in this environment, only Python 3.4 is available, and nobody dares to touch it for fear of breaking something. I said that this is a toy example, but we have situations that are pretty close to this. So how hard can it be? I've been developing for a few years, so this shouldn't be too difficult. Luckily, in Equinor, we have this amazing thing called AI. we even have our internal instance, so we make sure we don't disclose any data externally. Lovely. I have some prompt already prepared. And yeah, I know I can create a web application using Flask. So I'm just going to ask ChatGPT to create a simple application based on the requirements of using Python 3.4. And I want to have the server using Flask. Is it large enough? Well, it doesn't matter. I'm going to comment on it anyway. So this goes, and this suggests some code, some templates, some basic entry points, how to run it, where to find it. OK, awesome. And now I want to ask, OK, how can I handle YAML files? And it suggests you can use PyYAML. You just install it using pip install. And then you just use it like this. You load your string. You check it. You do stuff with it. And then you print it back. Awesome. OK. So I've done a bit of pre-work. I've already put all of this into a file, aggregating the inputs I got from ChatGPT. So I have my simple Flask application, and I have just one endpoint that reacts to both get and post methods. And if it's a get, it directly returns the template. If it's a post, it gets the text that is sent in the request. I print it out just for debugging purposes, because I'm trying this out. I want to see everything that happens. Then it loads the YAML code. It calls this checkConfig method that comes from the simulator. And then, of course, if it's not valid, just returns an error. Otherwise, it tries to print it in a more or less standardized way. And since it's a web application, I want to make sure it never crashes. I just catch all the exceptions, and I show them to the user, because at least the user knows what to do if something doesn't work. Yeah, don't do this. This is bad. And yeah, good. This should be trivial. Let's try to run it. Of course, I don't have a server running Python 3.4, so I just put everything into Docker container with some script. Sorry. So all of this stuff is available on GitHub if you want to run it with all the scripts and everything. Yes, so my app is in my app, obviously. And I just try to run it, python app.py. And it complains, because there is no YAML module in here. OK, fair enough. I have to install dependencies. As a developer, I would like to do it in a pipeline, but for the sake of the presentation, I'm doing it manually. So let's install Flask. Oh, there is some yellow stuff. I don't care. It's yellow. Let's install PyYAML. And OK, I'm getting some red stuff. It's telling me that PyYAML pretty much requires a Python version that is more recent than Python 3.4, which is the only thing I have. However, as I said, I've been writing code for several years. I know that PyYAML has been around for quite some time. So there must be some older version of PyYAML that can work for my case. So what I do, I just go to PyP. I look for PyYAML. Yeah, it's here. It's at version 6. OK, that's probably too recent. If I go back to my error message here, I see that it's trying to install Python 5.3.1. So maybe if I get a version older than that, it might fly. So I go to release history, scroll down a bit. It was 5.3.1. Let's try to get version 4 then. Version 4 are only beta pre-releases. There is nothing. So OK, I'll give it a try with PyYAML 3.13. 3.13. Go. Yes. Awesome. Let's give it a try. And it works. So I just go to my localhost, and yeah, there it is. That's my web application. Of course, I'm a thorough developer, so I want to test it as well. And luckily, I have some strings that I've already created to test this. I can try with malformed YAML just to make sure it fails on this. Yeah, I get an error, that's fine. I shouldn't run my simulator with that string. I can get something that, let's assume, is a potentially valid configuration for my reservoir. What the hell is this? I forgot to bring my mouse with me, and doing this with the touchpad is a pain. So I try this, and yeah, awesome. It works, it's valid, and it gives me back the configuration I want to pass to my simulator. Perfect. So I'm done. That was easy. Then, okay, let's deploy this, and call off my colleagues, have a demo, show them how to use this, and add an achievement to whatever your HR department is using. Make sure you get a nice salary increase the next round, and take a selfie, post it on LinkedIn, be proud of your work, then go out and celebrate. Awesome. You go out, celebrate, you go home, maybe a bit dizzy. You wake up the next morning, you go to the office, all happy to keep working on your new project coming in, and your monitor looks like this. So, what happened? It turns out that PyYAML has a feature that allows the Python code to be executed on load. And this is a feature. So it's expected to act like that, but of course, in my case, I should have disabled that. So what an attacker could do, or a malicious user, call it whatever you want, it can try to pass in strings like this, which is the way that PyYAML executes Python code, starting from files or strings. And if I try to do this, okay, I get an error. This doesn't seem to work. But since I get back a pretty thorough error message, I can see that some YAML code was interpreted, and the string I passed in that was supposed to run some Python code is not there. So maybe something has happened. And if the developer was not out partying, he would have seen this thing popping up on his console. So again, as an attacker, I can try different things. So maybe I can try to print out variables, environment variables. There is always juicy stuff in there. Run, again, same results. The YAML code it's the same YAML I've put in input. There was nothing, just the execution. But yeah, I get an error, but maybe it ran. So what I would like to do next as an attacker is to try to see if something is actually happening. And one possibility is, okay, let's see if from that machine I can reach out to the internet. So I can go to a website called webhook.site, and where you can just create, I've run this before, so it's showing differently, but yeah, it gives you a URL with a very long string of characters that you can use, and this website will notify you whenever this URL is hit by a request. So what I do, I pretty much just write the code here that would execute a GET request towards the webhook I just set up. Go here, and when I run this, I go back here, and yeah, I got a new request, just arrived. So as an attacker, now I know that that server where that Python code is running can reach out to the internet. So at this point, I can start doing all sorts of nasty stuff. I can, for instance, try to download something from there. I can try to send information from the server somewhere. But I guess the most juicy part is to set up a reverse shell and just get direct access to that server. So what I do, I just need my IP address, because I'm going to host, again, a listener here. Like I'm going to use another Docker to pretend to simulate the machine of the attacker. Yeah. And I made the script here just because I'm lazy, but this is just a call to NC. It's like one line of code. So this thing is listening now on port 10,000, and I need to know the IP of my machine in order to try to connect to it, which is this. And I've been running this presentation inside the corporate network, and that's the reason why I'm using Docker containers and doing everything locally, because some of these things might trigger some alarms if you do it on the actual network. And also, I know some of the websites I'm using, like for instance, the webhook thingy, it would not work on an internal network that is protected by firewall, for example. So I've done that. Here is my attack string. I just paste in my IP and grab everything, copy, and put in the application. Just submit. Same results here. As something happens on those machines, well, we can see this string again on the developer machine because there was some debug information. If there was some monitoring on the activity here, maybe this would have raised some warning. But of course, the developer was too busy to deploy this thing, was too much in a hurry. And in the attacker machine, I see that actually something has happened. So let's start having a look around where I am. OK. This is the attacker machine, and yeah, it's directly connected to the server where everything is hosted. So if I start looking around, I can see that there is a folder called confidential. And let's have a look at it. Yeah, there are, for instance, quarterly results in there. I can print out environment variables, and I see, well, I have some keys. I have some database admin's password and where the database is hosted. There are some keys to a key vault in Azure, and all sorts of useful stuff. And at this point, the attacker is in, and he could just pull anything from the web. So I just, yeah, it can pull stuff from the internet. So it could pull, for instance, Metasploit, or it could pull malware, a ransomware, and just run from it. And we're done. So, oops. Is this it? Was there anything better we could have done here? Obviously, yes. Normally, in the version you find on GitHub, I just jump straight to static analysis and software composition analysis. Just for the sake of exploring this a bit further, I've asked a couple of colleagues that have never seen this presentation to review the code and see what the results were. I got one here, and yeah. Of course, this code is bad, so they started finding a lot of stuff in here. And among others, there was this obvious, can this not use safe load? OK, fair enough, got it. It's, however, interesting that that was obviously the most dangerous thing in there, but it's kind of lost in this flood of comments. Still, it works. You had a senior developer looking at this. He could spot that there was an error there, and that gets fixed. And I have another example, which is more like straight to the point. I think, yeah, this comment here, log, load is unsafe. Yeah, this is probably spot on. OK, you know it's unsafe. You should not use it. Don't. I also tried doing a small threat modeling session by myself. Of course, it was easy because I knew the problem. And of course, if you look at it here, you clearly see that there is stuff coming from outside your trust boundary going into your simulation machine that you want to protect, and that's an obvious warning. Funnily enough, the first time I tried it, I didn't entirely correct. I didn't get properly how to model the IP coming in, and that's because I really didn't have a CI/CD pipeline. So again, this is a toy example. So it might be difficult because a lot of these pieces, I had to imagine them. But yeah, if you do threat modeling properly, you should detect it. There is still a risk that developers are not well versed in threat modeling, so they might miss some things. It's beneficial anyway, they will find other stuff, but be aware that this is not foolproof. Yes. Oh, and one thing I forgot. The code for the reverse shell, it looks a bit complex. And most developers react saying like, yeah, I mean, but that's super complex. Only very advanced attackers could understand how to write that. And they're probably right. But the thing is, I didn't understand that at all. I just went to a website called refshells.com, scrolled down to Python, and just copied whatever text working. Like there are 3 versions. I tried the 3 of them, and I picked the first one that was working. Easy. The other thing that would be the best solution for this kind of problem is to run dependency scanning and static analysis. So in Equinor, we use Snyk, but I'm pretty sure that this would work with whatever scanner you have. And yeah, I've imported it already, but I guess you can imagine how this works. You just connect to GitHub. Takes a while. Load my stuff. Let's see if the search field works here. I think we have too many things. Yeah. Demo app repositories. And yeah, it's running, it will import. In the end, it will look something like this. Hopefully. I am running on my phone connection, so it might be a bit slow. Yeah, it detects a Docker file, but that's just some infrastructure needed for the example. The interesting part is, of course, the requirements.txt file. And here it detects it actually picks a wrong Python version, which is interesting, but nonetheless, it picks up that there's a PyYAML as an arbitrary code execution vulnerability. And it's introduced. Well, it's because I'm using PyYAML 3.13, and it can be fixed by updating just to 4.2. So I could have used that instead. One thing I find it funny, and I always have to explain this in Equinor because we are using Snyk, here it says no known exploit, which is not obviously true because I've just showed that it is exploitable. The thing is, this is a toy example, and this vulnerability is so trivial that by now nobody is exploiting it anymore. So in a real context, in a real scenario, it's a bad thing. It's kind of unlikely that this would be discovered, but then you don't have to tell this to the developers. Just tell them that this is super dangerous. Yes. Also, this could have been detected by static analysis because, again, the ability to run Python code when loading YAML is a feature of PyYAML. And there are ways to just loading files more safely. The problem is the way I loaded that string. So if I go back to my code here and I enable the Snyk extension, which just run static code analysis in my IDE, let's go back here and let's see if it's running. Yeah, okay. Yeah, I get these nice red squiggly lines that tell me, yeah, you're deserializing untrusted data. And I think you can even ask it to try to fix it. Let's see if this works. No, it didn't. No, I didn't fix it, but okay. It's probably one of the others, but the suggestion here would be to use safe load, which specifically disables the ability to load to run Python code on execution. I mean, there is still a problem because I am deserializing data without validating it first, so that's also an issue. And there are a bunch of other issues, like I'm printing out untrusted data to the user, which could lead to cross-site scripting. So, I mean, this is bad code. And by running a static analysis tool in your IDE would help you identify those issues before you commit or even deploy them. All right, so key takeaways. Do code reviews. They're not foolproof, but they help. Do threat modeling. They don't detect everything, but they help. When you're writing code, run static analysis. I mean, again, it doesn't detect everything, but it helps, and it helps you thinking, and it points to the parts of the code that you need to think a bit more about. And of course, when you use third-party libraries, don't trust them blindly. Use a software composition analysis to check if the dependencies have known vulnerabilities. I mean, even widely used libraries like PyYAML can have serious vulnerabilities. And on top of that, as a bonus, whenever you deploy code, make sure you start monitoring your deployment for vulnerabilities, because the vulnerability can be discovered in the future. I can deploy something now using YAML 6.1. I can't remember what was the most recent version. And tomorrow, some of you might find a vulnerability in Python 6.1, and they want to be alerted by that, because I need to update it, I need to fix it, I need to make sure this doesn't have any serious implication. And if possible, establish routines for updating your libraries regularly. Don't just trust that the latest is picked whenever you deploy things. And I've used the requirements.txt file with no version specified. And the amount of people that actually do that is huge, and that's bad. Last but not least, we are responsible for the code we write. It doesn't matter if you use Copilot, it doesn't matter if you use ChatGPT. We can't blame Microsoft because ChatGPT or Copilot suggested something wrong. If we commit that code, if we deploy it, we take responsibility for that code. And this is something that we have to reiterate over and over and over, because there are many people in various companies that would really appreciate if AI could replace some of the costly developers that we have around all the place. It's important to know who is responsible for that code and who has checked that code and made sure that that code is safe. There is just one last piece that we haven't covered, and that is, how did the attacker figure out that I just deployed a dangerous service? Well, it turns out that this is the selfie I posted on LinkedIn. And if you look closely, you can see that it's visible. I'm using YAML and Flask, and the URL is visible. So maybe if the network was not properly protected, this could have led to the attacker to figure out how to attack this. That's it. Hope you enjoyed it. I think we have plenty of time for questions. If not, I'll still be around for a while, so just feel free to approach me. And again, this is available on GitHub. Just look in there, Equinor, and look for AppSec, and you'll find it there. Thank you.